I'm Ajit Garge, working as a solution architect at Ashnik, and I'm going to walk through I'm going to walk through a high-level architecture of enterprise Redis, along with some of the use cases of on the demo. So what I'm going to cover is Redis Enterprise architecture. I'm going to explain about my demo setup and the use cases like creation of the databases. Very simple, but then some of the features or some of the options are very useful to understand that. I'm going to show you how node level hierarchies work in enterprise Redis. I'm going to show you the multi-tenancy architecture, like how you can create multiple databases in a single cluster with the various options. And the last but not least, I'm going to show you the multi-cloud deployment or multi-region cloud deployment availability using the CRDT feature in enterprise Redis. So typical production grade deployment of Redis enterprise cluster is a 3-node cluster. You can deploy either on virtual machine or container, but make sure that you at least start with the 3-node of the cluster. Our preferred choice, what we recommend is to deploy the enterprise Redis on a cloud is self-managed cluster. That means you can deploy the enterprise Redis on a public cloud or even the private cloud with this with the infrastructure as a services. On the top of that, you can deploy that, and this will help you to control your cluster and also get the enterprise Redis features with the latest version. Redis is actually based on the shared nothing architecture, so that it provides you a multi-tenancy. You can run the number of shards in a single cluster. With this, you can actually utilizing the maximum number of infrastructure resources. You start with the minimum 3 nodes, and you can build a quorum as an N+1 architecture. It does provide a hierarchy within a cluster as a master-slave application. It also do the sharding across the multiple nodes so that it provides you the better performance. And also, it is easy to manage the cluster. You can see on my screen, I'd like to zoom the one of the node, and you can see on my screen that there is a 2-layer within a single Redis install base. One is the red square, which is nothing but community version of the Redis, which is provided the very good features of the logical database. And on top of that, there is a blue square, which is nothing but enterprise layer of the Redis, which provided the zero latency proxy and the cluster manager. So proxy provide the connections endpoint for each of the database so that it allow you to connect the database from any of the user or the application in a multi-tenancy mode. It manage persistent connection. It provides you the multi-threaded connection to boost the performance and provide just-in-time instructions and multiplexing it. It does forward the connections from the database port endpoint to the master node. Now, if I further go in detail and show you how the multi-tenancy database work in Redis in a cluster is that, so you can create actually the different database with the multi-tenancy, which is a really great feature in enterprise Redis. And you can, with this, you can save a lot of the cost on your on the infra provisioning of these shards or for this database. And all these application you can manage the workload in a single cluster. It does provide the sharding, so as a replication like master slave replication. Along with this, it also provides the isolation of your connection and separate out your connection to the particular database, which is connected to the from user to database with the Redis RBAC policy. Again, Redis does provide active-active geo-distributed replication called CRDT, which is a conflict-free replication data type. And it actually solves your two problems, latency and conflict. If your application running in a zone 1 or region 1 or maybe on a cloud provider 1, say let's say Singapore, and your users are maybe in India, and the latency may be add when they are connected accessing the data. Similarly, if you have a user in Singapore and your cloud provider deploy the Redis in India, deploying the Redis, and that also get added the latency. So to solve that, what you do is that you deploy the enterprise Redis on a both the geo, right? So that users can access the data on its own local cloud provider. Yes, it definitely solves your problem. You can create the replication across the geo and then get a single view of the data across. While this is helping you to solve the latency problem, but then when the data is merges across the geo, it will start conflicting, right? But the CRDT provide you the 6-way of conflict resolution algorithm, which help you to resolve the conflict automatically. So without worrying of the conflict and the latency, CRDB help you to replicate the data set from cloud provider 1 to the cloud provider 2 and vice versa. In this case, maybe from Mumbai to Singapore and Singapore to Mumbai back. So this will help you as an active cluster solve the data consistency problem, conflict resolution problem. And if the one of the cloud provider is down, you still have another cloud provider where the data is get replicated. I'm going to show you a demo on this feature. So this is my demo setup where where I have deployed the 2 Redis cluster, one in cloud provider 1, which is in region 1. In my case, I have AWS region 1, and another is in another cloud provider as a region 2. In my case, again, AWS region 2, right? So, and both cluster are 3-node cluster deployed on an EC2 machine. And this is a slide. You can see how enterprise Redis help you to achieve a 0 data loss without impacting the performance on a different stages. Start with the simple process failure till your completely region or cloud is failed down. So you can see in a different event of the failure and the mechanism how to recover that. Start with the instance recovery, fast recovery, as well as the disk-based recovery. Now let me go and show you how I show you a demo on how my different use cases will work on an enterprise Redis cluster. I'll start with the simple first, creating the database. So let me show on my databases. So I have already deployed the Redis cluster. This is a link of cluster 1. This is a link of cluster 2. And I'll straight away start deploying one of the database. I'm just going to show some of the features and some of the options when you're creating the database. So this is the first screen where it asks you whether you want Redis database or Memcache database. It does support both. It does provide a single region deployment or geo-distributed deployment. Geo-distributed is nothing but CRDT, which I mentioned in my slide. So to showcase database, I'm just taking a single region and then show the next. In my slide, I need to give the options like maybe database name like app3. I'm going to app3, and this is obviously Redis is on a memory, so it's showing the RAM, and you need to provide the memory, how much database size you can increase and decrease in a later stage. And do you want replication within a cluster or not? It's a master slave replication. So I'm going to check yes, I want replication because I want high ability. And there are various modules of Redis. You like to add some modules like graph, Bloom, JSON, search, time series. You can choose that. I don't want right now, so I just remove that. And you have a persistency option as well. So enterprise Redis do provide the persistency option, like you can sync with the Redis database, which is in memory, to the disk with the end of the every write or every second, or taking a backup like every hour, 6 hour or 12 hours. I'm just taking a snapshot of every 6 hours. You can provide the username and password for this if you wanted to protect your database. I'm going to show you some of the advanced feature, though I may be not use in this use case. Then just show some of the advanced features. So this is a database clustering, which is I mentioned you the sharding, right? So you can create the sharding across the nodes in a same cluster. I'm going to take a sharding like I want a 2 shard for this database app3, right? And there is a different policy of sharding like standard hashing policy or custom hashing policy. And with this sharding, I also I also check mark the replication, right? So total number of shard is 4, 2 master and 2 slave. Along with this is again one of the important option like data eviction policy, right? Redis is a in-memory database. You need to make sure that you have an eviction policy. When the eviction policy is whenever your database reach to the maximum memory occupancy, how you can evict the database, how you can evict the data. So there are different options like either you no evict or you can have a TTL base, you can have a least redundancy use, or you can have the least frequency use. So these are the various options you can use for the eviction policy. I just choose LRU, right? And you want to take a periodic backup. I already taken periodic backup. You can choose that. And these are some of the basic alerts which enterprise release provide, like data set has reached the maximums with percentage or higher than that, it can send you over the email, right? So this is one of some of the options. I'm just activate that. Yeah, while this database is creating on a GUI, I just want to show on my CLI screen. Okay, so here on my CLI screen, all the 6 nodes, the green one, which is a cluster 1, while red one is cluster 2, right? So all these are 3 nodes, which is showing on my screen. So I'm just want to check whether my, how I can check my database status. So there is a utility called rel admin. You can just type on rel admin on your SSH screen or black screen, and then you are in rel admin prompt. I just want to check the status. Yeah, so you can see the status is a 3 node cluster with the IP address, host name, and their memory consumption. And these are the database. Some of the databases are already created. I'm just going to tell you about this. So my app3 is just I created, which ID is 11, right? So this is the endpoint of the app3. This endpoint of database can be utilized by user or application multiple times. So you can use a multi-tenancy kind of thing within a single cluster. And these are the endpoints of the DB ID, app1, app2, app3, app4, right, which I created. And these are the shards, number of shards. So like if I take example of app4, app3, sorry, which I just created, which I'm highlighting. So app3 has a 2 master and 2 slave shard. You can see master shard is on node 2. Another master shard also on node 2, while slave shard is on node 3, right? So you can see like 0 to 8191 master slave like this, right? If you want like master shard on node 2 and another master shard on maybe a node 1, you can do this shard migration. There is a command called migrate, and then you can give the shard number and you can migrate the shard. So up to you. You have flexibility to migrate the shard as well. Like this, this is one of the example how you can create that database with a different shard spread across the cluster. But I have some another example which I like to show. Like for example, this is a app1. App1 is basically the only single database, right? If you look at this app1, only single database with only single shard, master shard. There is no hierarchy I have chosen for this, right? While app2, which is another database, has a only hierarchy, right? Replication, master and slave. While app4 here is basically again a 2 shard, but master and slave shard. But this app4 is a CRDB. That means this is available on cluster 1 as well as on a cluster 2. I can show on a cluster 2, app4 is already available. Stop this on a cluster. I'm on right now on a cluster 2 on node 1. I can say the rel admin, right? So if you look at this, app4 is available on cluster 2 with the master slave shard, right? But the database like DB1, sorry, app1, app3, and app2 is not there because I have not created CRDB for this, right? So likewise, you can create a multi-tenancy of the database using a single cluster and you can create a geo distributed database as well in Redis, right? So this is how you can create the database in a Redis with the multi-tenancy option. Now I'm going to show you how you can get the high ability of the database. What I'll do is that for this, I have a 3-node of cluster and a cluster 1 on one geo. I have another 3-node cluster which is marking red on another geo, right? So I'll just check high ability of this cluster. What I'll do is that I will just down one of the node and then see how I can achieve the high ability within the cluster itself. So what I will do is that this I'll just take example again for the app 2. App 2 here, I have a master node, master shard on node 3, while node 2 on slave. So what I'm going to do is that I will off the Redis services on node 3, so that I expecting that node 2, which is right now slave, become a master, right? That's my use case. And once the node 3 come back again, this supposed to be a slave for this master, right? So I wanted to check that first node 3 become master, and second node 3 when come back, it's become a slave of the node 2, right? So let's do that. I'm going on node 3, which is over here, and then off my Redis services. Of the Redis services, I have a command, right, on node 3. Okay, look like my Redis service on node 3 is down. Let me check my status. Okay, so you can see that whatever on node 3 is showing the error, which is basically the down. So my app 2, this app 2, right? Now if you look at this, node 3 is still showing the master. Let me sometimes not refresh. Let me status again, right? Refresh. You can see that node 2 become master. It was earlier slave, right? While node 3 was a master, now is a slave for this master, which is still down. So it is in a transition phase to become a slave of this master, but still not up because node 3 service is still down, right? As soon as I up, this become a slave as activated for the node 2, right? So now the node 2 data is still there. Your users can still access the data, even one of the node of the master is failed down. Now what I'll do is that as a part of this use case, I just up again these services on node 3. Start. Okay, my services are started. Let me check the status. Okay, yeah, you can see now on app 2. So node 2 still a master, while node 3 now is slave and is activated. So like this, within a node, within a cluster, if one of the node goes down, your data is still not loose. Your user still connected to your cluster, and you can save. You can do the zero latency or zero downtime that get managed by zero latency proxy, right? So this is how you can achieve the node failure within a cluster. Now, our next use case, which is a very important use case, is that how you can achieve the multi-tenancy deployment or multi-cloud deployment. In case you have a multiple application running on a cloud provider number 1 on a one geo, and the similar application is deployed on a cloud number 2 provider number 2 on another geo, and you want less latency, you want conflict-free replication. At the same time, you wanted to achieve the DR as well. If one of the cloud vendor is down, you still can achieve without losing any data and impacting the performance. You can still achieve the DR situation. How you can do that? So what I'll do is that we already created the CRDB for app 4, which I mentioned. This is my app 4, right? Just get the status on. Right, so all of the up. This is the app 4. which is in CRDB. You can see there is a one master, one slave for app4 in cluster number 2, while this is my cluster number, cluster number 1, and while this is my cluster number 2, I can see the app4 over here as well on node 3 and node 2 with the master slave, right? So what I'm going to do is that I'm going to down all the Redis cluster on cluster 1, all the node of the Redis cluster on cluster number 1. So just trying to simulate the high availability situation where completely cloud of the one of the region is down, while you still have access of the data which is replicating to the another cloud on a cluster 2, right? I'm going to show how it is going to see and impacting on your cluster. So I'll again use the same command. What I'll do is that I'll first try to add some data and show you how it will work, right? So let me add some data on a cluster 1. So to adding the data or inserting data or updating data, you can have a Redis CLI. You can access Redis CLI-P. For each of the database, you have a port number and endpoint. You can access that. So I'm going to access app4, which is running on 1005. So I go to 1005, right? This is a 1005. I can add some data like set key 10, maybe like ABC, right? I'm adding over here set key 10 ABC, right? You can get key 10 ABC here. This is a cluster 1, right? And here I'm going to add another one data like Redis CLI -P 1005. I'm sure it's 105. Let me check on 005. Yeah, 1005. Right? Maybe over here. Yeah, it's 1005. Let me check first. Get key 10. So ABC is already there, right? Because it is replicating from cluster 1 to cluster 2. I'm right now on a cluster 2. Now I wanted to add a key 10 and see whether it is coming on cluster 1 or not. So set key 11, sorry, set key 11 XYZ, right? Get key 11 XYZ. Let me check 11 key number. Get key 11. So XYZ replicating over here. You can see the data, single view data across the geo using a CRDT, right? So this way you can get the conflict-free data with less latency and a single view of the data. Now my use case is to down the whole cluster itself and simulated that the complete cloud is down and you still have access of the data, right? So let me check on this over here. My command of down the all stuff. I'll down one by one services and see how it impact. So I'll start with this node 3 with the cluster 1. I will down this, right? And I will down this as well, right? So my all the services are down over here on this cluster, and you can see I think on my here as well. It may be taking some time to come, but here I can show you on a cluster 2, right? This is still Redis F4 is still there, even the cluster 1 is down. You can still add some data, right? Let me add some data like maybe key 12, right? Set key 12 after down, something like this. right? And get key 12. So after down is in cluster 2. Now assume that my cluster is again up, right? And see whether it is taking this data from the cluster 2, right? Let me on the cluster one by one. Stop, then I can start it. My proxy is not. It takes some time to come proxy. Some internet issue at my level. I started on cluster 1. Let me add on cluster 2. Sorry, node 2 on cluster 1. Then I'm again putting start over here. Let's do one by one. Yeah, it started node 2 and now node 1 on cluster 1. Right, so let me give rel admin. Sorry. Right, now check the status. Yeah, so if you look at this app 4, this is an app which we have in CRDB is okay now to accept the connection. Now let's see whether the data is synchronized or not over here. So I'll go to Redis CLI, Redis CLI -p 1005, right? And then I get key 12, right? This is a key after down. So if you can see that the data which is on cluster 2 after down is also there in cluster 1, right? So you automatically get sync even after the down the whole cluster and come back again. So this is a way how you can achieve the high availability across the geo as well. And even I shown you how you can achieve the availability within a cluster. I also shown you how you can get the multi-tenancy with the Redis, with the creating the multiple database with the single shard, multiple shard, with the cluster, without clustering, with sharding, without sharding, and across the geo.